Hi, I'm Matthew from OpenResty Inc. Today I demonstrate another cool feature in OpenResty Edge. That is, how to use our rule-based domain-specific language, the Edge language, or EdgeLang for short. The user can use EdgeLang to write complex gateway rules for custom authentication, request and response rewriting, dynamic upstream routing, and many more. The rules usually run much faster than handcrafted Lua code. For example, the EdgeLang compiler emits efficient native code running on gateway servers. The EdgeLang compiler is extremely efficient. It implements many advanced optimization techniques. It supports combining regular expressions referenced by all the EdgeLang rules into a single-state machine. This way, it can immediately know which rules and which parts of those rules are matched by scanning the request data only once. It also supports combining constant string prefix and suffix patterns into single tree data structures across all the EdgeLang rules. Let's go to a web console of OpenResty Edge. This is our sample deployment of the console. Every user has her own deployment. We still use our continuing sample Edge application, testedge.com. Enter the application. We have a page rule already defined in a previous tutorial. This page rule sets up a reverse proxy to an upstream. We can add our EdgeLang code here. Let's add our first rule. First it comes the rule condition part. When the URI is /foo/. Then we use the arrow to complete our condition. After the arrow, we specify our actions to take when the conditions are met. This action initiates an HTTP redirect to the /bar/page. Save the rule. As we can see, the EdgeLang specification consists of rules. And each rule comes with two basic parts: a condition and a consequent consisting of actions. The condition and the consequent are connected by an arrow sequence. And the whole rule is terminated by a semicolon character. This is just the simplest rule. We can add as many rules as we like. Each rule can also take many conditions and/or OR together. And a rule can take many actions in its consequent part. Let's make a new configuration release to push out our new changes. As always, click this button. Ship it. Our new release is now synchronized to all our gateway servers. Now the new page rule has been pushed to all the gateway clusters and servers. Our configuration changes do not require server reload, restart, or binary upgrade. So it's very efficient and scalable. On the terminal, we send an HTTP request to a gateway server resolved by DNS via the curl command line utility. Note the response header has no redirects. Next, let's send an HTTP request with /foo/URI. Note that the request has been redirected. It is being redirected to the /bar/ location. Our EdgeLang rule works. Let's test another URI with the prefix /foo/. The URI takes an extra suffix, blah/. Send the request. Note that the EdgeLang rule was not hit. This is because our EdgeLang condition needs to match /foo/ exactly. Let's edit the condition in our EdgeLang rule to handle such cases properly. Click the edit button. Delete the original condition. Change it to matching the URI prefix /foo/. Save the rule. Make a new configuration release again. Back to the terminal. Let's send our previous test request again. It still takes the blah/URI suffix. Send the request. It triggers a redirect and thus hit our EdgeLang rule this time. Next, let's send an HTTP request without any extra URI suffixes. It is still a hit. We could use EdgeLang in many different places of the web console. For instance, EdgeLang can be used to add custom rules for WAF, or the web application firewall. Create a new WAF rule. Write EdgeLang here. EdgeLang is a very powerful language with many features. Feel free to read our EdgeLang user manual to learn more. There are many code examples. And they explain various usage of EdgeLang in great detail. That's what I'd like to cover today.